Hi everyone, and welcome to the Chapter 2 lecture discussing frequency distributions. The formal definition of a frequency distribution is an organized tabulation of the number of individuals located in each category on a scale of measurement. I personally like to think of frequency distributions as being a fancy tally system. The simplest version would be something like this, where you have a tally of each person's favorite jelly bean flavor. And you can see that in this example, cherry won with the vote being 17 people's favorite. But you can imagine that in psychology, we might be interested in more complex data. Maybe we're interested in how many hours per day children are playing outside. We send a questionnaire to parents and add up the number of scores per group. Then, instead of making tallies, we simply put the number of people in that category. And what this does is allow for easier interpretation of the data. If you were simply given each of these scores all jumbled up, it would be more difficult to understand. So there are 4 steps to making a frequency distribution in this class. I'll provide examples of this in a moment, but first you make a table with 3 columns. You label the columns, first X, then F, which is italicized, and %. X refers to all the scores available. F is the frequency, and then % is the percentage of that frequency. In column 1, you list all the scores you have available, and you list them from highest to lowest. In column 2, put the frequency of the score, how often it happens. Then in column 3, you put the frequency percentage. This is calculated by dividing the frequency by n, which is the total sample size, the number of scores in your sample, and then multiplying it by 100. For instance, say we're interested in examining the literacy rate in the United States, and we want to know how many books people have read in the last year. We decide to start small and just ask around, and these are the numbers we received. And you can tell that some people may not have finished their books yet, hence the decimal, but from here we need to count how many people we received answers from. There are 29 scores here, so Rn is 29. So let's take those scores and then list them out from largest to smallest, and make sure to only list each one once. This is your X column showing the scores of your data. And as you can see, some of these numbers show up multiple times. List how many times they show up next to your score to create the frequency column. It's important to double check that the sum of your frequencies, remember that sigma means sum of, equals the total sample size. We want to make sure that there are only 29 scores here, and that we aren't double counting or leaving anyone out. The last step from here is to find the percentage. To find the percentage, we divide the frequency by the total sample size and multiply it by 100. We typically round to the nearest hundredths place, so 2 decimal places. Taking this first score, 5 comes up 1 time. The frequency, 1, divided by the total sample size, 29, times 100 is about 3.45%. The next number, 4.5, comes up twice. 2 divided by 29 times 100 is 6.9%. Go ahead and take a moment to pause the video and calculate the rest. The answers will be shown in 5 seconds. Here is the full percentage list and the completed frequency table. This is what I am expecting from you in the homework assignment. Note that the top of column 3 has the percentage symbol, and make sure to double check that the sum of the percentage is roughly 100%, though it may be off a few tenths of a percentage due to rounding. The example given works really well when there's a limited number of scores. But what if we have dozens or even hundreds of possible outcomes? The frequency table might be hard to interpret. To help make sense of a lot of data, you can use a group frequency distribution, where there are intervals for the X values rather than individual scores. You can see on this example that there's a range of 5.0 to 5.9, 4.0 to 4.9, and so on. The frequency and percentage is calculated in the same way. This just helps to simplify that data. I personally like to use group frequency distributions to examine grades and better visualize how many students earned A's, B's, and so on. When you're doing this, you just have to make sure that you're choosing intervals that make sense and are chosen for a reason, that they include all possible numbers, and that there are equal intervals. You wouldn't want to have some intervals that are bigger than others because then it would be hard to compare. Once we have our frequency distribution, we'll want to plot the scores using a graph. And we have a few different options to do this based on the data we collect. After we plot it, we need to look at the distribution of scores and determine whether it is normal or skewed. And if it is skewed, we need to determine if it's a positive or negative skew. The first graph we'll talk about is a histogram, which shows the distribution of scores using connected bars. There is one bar for each value, and it's plotted such that the x values are plotted on the x-axis, which is the horizontal line, and the frequency is plotted on the y-axis, which is the vertical line. The example here is from the textbook and shows frequencies of stress ratings. Looking at their data, a stress rating of 10 shows up 3 times. So it's plotted at the 10 mark and extends up to the number 3. And this is done for each of those numbers. You can also plot this information using a frequency polygon, which connects dots instead of bars. It's plotted the same exact way and shows the same information. It's just a different way to visualize the data, and I find them especially helpful for examining trends over time. Lastly, we can make a bar graph, which is plotted the same way as a histogram and frequency polygon, but the bars do not connect. And this is because we're plotting different categories. The previous example looked at stress scores and only stress scores, which is why the bars were connected. This graph is looking at different locations such as vehicle, home, work, and office, so they are separated. Once we have the data plotted, we'll want to look at the distribution of scores and see what shape the data fall into. What does the spread look like? Is it symmetrical on both sides? Is the greatest frequency in the middle? If so, we call this a normal distribution. To give you a better idea of this, this is a typical normal distribution. If we were to draw an imaginary line down the middle, the scores fall into a symmetrical shape, and again, the greatest frequency is in the middle. However, there are different types of normal distributions. The first is a heavy-tailed distribution, where again the distribution is symmetrical, the greatest frequency is in the middle, but the tails, the endpoints of the distribution, are thick. Likewise, you can have a light-tailed distribution, where the tails are thin because the scores are centered around a common value. But say you draw an imaginary line down the center of the distribution, and it's not symmetrical. Instead, the majority of scores are toward one end of the distribution. We would call that a skewed distribution, and skews can be either positive or negative. When the majority of scores are toward the left of the distribution, it's a positive skew. And when the majority of scores are toward the right, it's a negative skew. These might go a little contrary to what you would originally guess, so make sure to know the differences between these. So let's bring back that example we were using earlier. As a reminder, this was a frequency table looking at the number of books read. If we were to plot it, we would use a histogram because we are only measuring books. If we were measuring books and movies and other forms of media, a bar graph would be more appropriate. So plotting the scores on the x-axis and frequencies on the y-axis, this is what our graph looks like. Next, we can examine the shape of the frequency distribution. Drawing that imaginary line down the middle, we can see that it's not quite symmetrical. there are more scores on the right, meaning that it's negatively skewed. Here's that same information presented in another way to highlight the shape of the distribution and show that it is indeed negatively skewed. And that is all I have for you. Please let me know if you have any questions, and I hope you have a wonderful rest of your day.